Hi friends, welcome to Programming Languages for Civil Engineering students. In this video, I am not going to discuss about programming, any programming, but I am going to introduce a software which is very useful to understand the structural dynamics for the Neophyte students in structural dynamics or earthquake engineering. Okay. This is the nonlinear pro. Okay, let us know what is this. Let us know what brief about this software. Okay. First about Nonlin. Nonlin is an educational program for learning the concepts of structural dynamics and earthquake engineering. Okay, and this is very powerful software to understand the structural dynamics. Okay, I am going to show one example. Okay, I am going to demonstrate one example. Let us first you change this to metric units, unit type metric, and meters and kilonewton select, and then dynamic force applied as ground acceleration. Okay, then we have to give the enter structural weight in force units, that is kilonewton, some like that. Let us say some 100 kilonewton, whatever it may be. Then you have to give the input damping. Then you have to give the damping. Enter structural damping in percentage, critical units. Let us say 5%, whatever it may be. Okay. Then you select as this as linear. Okay, linear. Then you have to give the stiffness. The stiffness, let us say some 68, some 300. Okay, some 300, and okay, some 300 like that. Okay, here you can get a period 1.158, the frequency that is 0.863, and frequency, that is circular frequency, you got 5.424, and the damping 5.531. okay, then mass 10.197 kilonewton second square per meter, gravity, this is a 9.807 meter per second square. Okay, all these we got the dynamic properties of this this single degree of freedom. Suppose I want to give the ground motion. Let us say I am selecting 1940 El Centro. Okay, after selecting, we got there some colored icons. This colored icons is nothing but we have gave the all inputs. Okay, first we have to run this by clicking this green arrow button. Okay, we already ran the analysis. Then okay, it is completed. And if you want to see the response of the structure, just you click here, time history plot. Then after you will get, this is the displacement of the single degree of the freedom in meters. This is the time history displacement. And then so we don't want this. And total acceleration, we will get total acceleration. This is the total acceleration. If suppose velocity, then we will get the velocity also. Then the displacement, we will get displacement. Okay, here also we will get a relative the spring, that spring. Okay, and whatever it may be, we don't require this. Okay, then after these are displacement in computed hysteresis plots. Okay, we don't require this also present. And then here, these are the, if you click here this results, then you will get what are the our input values, and we will get the output values, the summary of the response spectra, like that. A summary of the response spectra. We got like the 300 structural weight, 100 kilonewton, structural damping, that is 5%, and property derived from input. Whatever we are given here input, and the structural dynamic, the structural properties are calculated. Okay, they have written program like that. Okay, summary of the response maximum inertial force, and maximum damping force, and the spring force, and computed maximum computed displacement. This is the displacement, and the maximum computed velocity, we got like that. Okay, then okay, everything is done. Okay, then we want the animated response of this single degree of freedom. Okay, just you click here, then you will get the response is started for L center ground motion. What is our response? So you can see here the structure is moving. So in this way, whenever the earthquake strikes, the structure moves. Okay, when we give some earthquake ground motion, the structure moves. We can make an app like this by using MATLAB or any other programming language. Okay, of course I have already created very similar to like this in my previous sessions, previous videos. Better watch them once. See, then the structure stops. The structure stops. What do you call it? The structure stops vibrating because the time period is finished. The time ground acceleration time is finished. Okay, this is the simple way. Then if you want to, maybe there is some. Okay, in this way we can create. Suppose if you want to just I am willing to put the zero damping. Okay, let us say here 100, something like that. Is linear and zero damping. Just I am giving zero damping, and let us say here I am giving 300. Okay, 300, and I am going to give some earthquake, and then after running, and you can see here this is the displacement. If you keenly observe, the displacement is same because the damping we have not given the damping particular, we have given zero damping. So zero damping, the response is constant. You can see here the response is constant. You can see acceleration also, mostly it is constant. The response is not decreased, not decreased. Okay, this is the way. So you can see here after clicking, then you'll get the structure responded more than the previous one. You can see here the structure responded more. You can see this is a displacement. You can see here the displacement is constantly, it is increasing. Moreover, it is constant. Okay, because we are not provided the damping to the structure. Okay, and okay, so that is input ground motion, that is 36. Now you can see here this is time. Okay, this is time, and runtime error, there's some error is there, problem is there. Okay, this way we can easily create